The popularity of aluminum extrusion has increased greatly in recent years, thanks to its benefits and applications. You've probably heard about this innovative product manufacturing process and wondered what it entails. In this video today, I will put you through the step-by-step aluminum extrusion process and its benefits. Before we get into that, let's start with the most important question. What is aluminum extrusion? It is the process of forcing aluminum alloy through a die with a predetermined cross-sectional profile. The aluminum is pushed through the die with a powerful ram. When it comes out, it takes the shape of the die. For example, imagine squeezing your toothpaste from its tube. As you compress the tube with your hands, the paste comes out in the shape of the tube's opening. This is a simple illustration of how aluminum extrusion works. The toothpaste is the aluminum alloy, your hand is the ram, while the tube's opening is the extrusion die. The aluminum extrusion process involves the use of dies, and there is no limit to the different die shapes available. Therefore, this process can produce so many shapes. It can help create solid shapes that have no enclosed openings, hollow, with one or more openings, and semi-hollow shapes that are partially enclosed. Also, you can choose to create custom extrusion shapes with various interlocking designs and color profiles. Now that you know what aluminum extrusion is, let's check out the different steps involved in this technique. The first step is the preparation of the extrusion die. In this step, the manufacturer needs to create a round-shaped die or use an already available one. Before loading the die into the extrusion press, there is a need to preheat the die to 450 to 500 C to extend the die's life and ensure even metal flow. Then, the machinist will cut the billet from a long piece of metal material. The billet is a cylindrical block of aluminum metal. After cutting, the billet will be preheated to about 450 to 500 C to ensure it is soft enough for the operation. Once the billet is ready, the billet is transferred into the extrusion press mechanically. There are two main processes to carry this out: direct and indirect aluminum extrusion processes. In direct extrusion, the billet is placed inside a heated wall container. After this, a moving ram the aluminum through the die at very high pressure. In this technique, the ram and the billet move in a forward direction. The indirect extrusion process is a backward technique. In this case, the die is stationary, but the aluminum billet and container move at the same time. Machinists often use a long stem to keep the ram in place. Unlike direct extrusion, indirect extrusion ensures better heat control to give a more consistent product quality. By the time we get to the next step, the billet is malleable and already inside the extrusion press. The hydraulic ram now applies over 15,000 tons of pressure to push the billet into the container. After this, the aluminum alloy expands to fill the walls of the container. At this stage, it is important to properly correlate the extrusion speed, pressure, and temperature. This will ensure that the process is steady and the extruded segment is consistent. It is also essential to consider a billet temperature that ensures a short production cycle. The temperature should also not affect the component's tolerance and surface conditions. The next step is the continual application of pressure to the aluminum material as it gets pressed against the die. This way, it passes through the die openings in a completely formed shape. You also need to consider the extrusion ratio at this point, as it will determine the degree of mechanical work you will carry out during extrusion. A high extrusion ratio will attract greater pressure, while a low extrusion ratio will demand minimal work. After that, a puller will hold the extrusion in place, protecting it as it leaves the extrusion press. As the aluminum moves along the table, a fan or water bath is used to cool it. This step is known as quenching. Temperature is also essential at this stage because there's a need to cool the extrusion further. The extrusion is moved to the cooling plane, where they will stay and cool down to room temperature. After cooling to room temperature, there might be twists in the extrusion shapes, and it is important to correct this. A stretcher is used to make the correction. The stretcher helps to hold the profile on both ends, which is pulled until it is fully straight. Now that we have a work-hardened and straight extrusion, the next is to transfer the extrusion to a finished saw table where we cut it into specific lengths. After sawing, the operator can move it into an oven to ensure proper aging to the correct temperature, usually T5 or T6. This usually marks the completion of the extrusion process. However, there is a final step where manufacturers carry out secondary operations on the workpiece. It involves heat treatment of the extrusion profile to improve its characteristics. Adding surface finishes also enhances their appearance and corrosion resistance. Knowing the process is not enough, you also need to know the benefits of aluminum extrusions. Extruded aluminum parts are good conductors of electricity. They are also excellent heat exchangers and do not weigh too much when mounted. Therefore, they are used in various electrical applications such as busbars, modern LED lights, and solar panels. Most display equipment you see at exhibitions or trade shows are also made with extruded aluminum. This is because it is easy to design extruded materials so that the pieces will interlock, and assembling them will be easier and quicker. They also support numerous surface finishes to ensure durability and better aesthetics. Likewise, extruded aluminum has excellent tensile strength and strength-to-weight ratio. Therefore, it is an ideal material for engine blocks, roof rails, vehicle chassis, and other automotive components. Their strength and lightweight properties also make them valuable in the construction industry. Working with the best manufacturing partner will help you get the best results for your aluminum extrusion project.
The process starts with a die being loaded into the press. The die has openings that will create the profile when the aluminum is pushed through. Next, the raw alloy is brought to the press in the form of a billet. The billet is a solid cylindrical length of alloy that can be up to 72 inches long. The billet is then placed into a heating furnace and heated to 900 degrees Fahrenheit. This temperature allows the billet to become soft, yet still maintain its shape in a solid form. Note that the aluminum has not changed color, even as it exits the heating furnace at 900 degrees. The heated billet is now loaded into the press. As pressure is first applied, the billet is crushed against the die. Then, as the pressure increases, the soft but still solid aluminum has no place else to go and begins to squeeze out through the opening of the die to emerge on the other side as a fully formed profile. The extrusion is cooled after emerging from the die, either naturally or through the use of air or water quenches. This is a critical step to ensure sufficient metallurgical properties after aging. The extrusion is then transferred to a cooling table. A stretcher is used after the profile has been cooled to straighten the extrusion and correct any twisting that may have occurred after the extrusion. A finish cut saw is used to cut the profile to the specified commercial length. Extrusions are then placed on racks as they are prepared for the aging process. Extrusion alloys reach their optimal strength through the process of aging, sometimes known as age hardening. Natural aging occurs at room temperature. Artificial aging takes place through controlled heating in an aging oven. The aging oven further strengthens or hardens the profile through controlled thermal treatments that affect the metallurgical structure of the alloys, yielding maximum strength, hardness, and elasticity for the profile. Once the extrusion process is complete, the die is removed from the press and cleaned of any residual aluminum. After cleaning, the die is inspected and prepared for the next time it will be used to extrude this profile.